Hello, my name is Sarah Anusaji, URK24CS1108, and today I will be explaining the first experiment of the Data Science and Ecosystem Lab. So, in the first experiment, these are the questions that are to be done. So, in this, we are supposed to create a NumPy array. Let's go with the first question. So the first question says that we have to create a NumPy array representing the body temperatures of 8 patients, and we have to print the array. So in order to do so, what we have done here, uh, I'm using the Python IDE here for doing this. So what I have done is, first I have imported NumPy, and this is the syntax to import that. Okay, we have to type in import NumPy as np in order to get the library. Then I have printed my name here, uh, and then we are using the np.array function in order to create an array. So we have given the array name to be temperature. The temp is the full short form I've given. And we have, entered all uh, the list of temperatures that are to be given. And then we have, printed the name of the array. And upon doing so, that will be printed here. So I have run it, and then here we have the output. So 98, 101, 100, 102, 99, 97, 103, and 104 have been printed here. It's really simple. That is all that there is to the first question. We have successfully entered the body temperatures of 8 patients. Okay, now for the next NumPy question, we have to create arrays using NumPy. Sorry. So the first one, what we have to do is that we have to create an array of 10 zeros to represent placeholder blood pressure readings. And then the second one, we have to create an array of 5 ones to represent patients who tested positive for a particular marker. And for the question C, an uninitialized array of size 5 using empty array for future heart rate. So for the first one, what we have done is, like before, we have used this input numpy as np. Then we have given a is equal to np dot zeros. What this does is that it will create uh, an array with 10 zeros in it. Okay, and for b we wanted ones. So this function np dot ones, what it will do is that it will create uh, an array of 5 ones in it. And for the last one, we are creating an empty array of size 5, wherein which it will be empty. It's just that we are reserving 5 random places for the what for the uh, which is mm, saving 5 random spaces. Here I'll show you. So we have printed a, b, and c. So where do we have that? So yeah, here one, we have 10 zeros printed, we have 5 ones printed, and we have random 5 digits or like things printed here, because because it was empty. So it can be randomly, any random digits or numbers can be printed in between. Okay, next for the third question, we have to generate a random array of 15 integers between 60 and 120 to represent heart rates, and we have to print its dimension, shape, size, and data type. So what we have done, the same thing again, import numpy as np. I've printed my name. Okay, and then we have, what we have done is that we have given heart, and then heart, and we have initialized and we have used the function np.random_radian. Now what it does is that we have they have given us a range, right? 60 to 120. Okay, that is our range. Between that range we need 15 integers. So first what we'll do is we write the starting number of the range, and second the number that would 120 is the number that ends, so we have to uh, add one more add a plus one so that we get the range right. So 121. So 120 is the ending number. We have added 121 so that 120 can be included. And then 15 is the number of digits that should be randomly taken. Okay, and then we have run this and we have got uh, random numbers, 15 random numbers, which are from 60, which is which is between the range 60 to 120. Okay, now we have all that. First we have printed heart. As you can see, as you guys can see, the range has been printed between. And then dimension. Now dimensions, we can use the function heart. Heart is the range that we have initialized. Okay, heart dot ndim will give us the dimension, like so. Dot shape will give us the shape. Heart dot size will give us the size, and dot d type will give us the data type. So this is all that for the third question. Now next is the fourth question. So we are supposed to create a numpy array of patient IDs from 1 to 20. Okay, and we are supposed to extract the first 5 patient IDs, extract patient IDs from 6 to 10, print every second patient ID. Okay, so in our what we've done here is same, import numpy as np patient. We have initial np dot arrange. Now we are arranging from 1 to 20, so we need exact, not random, we need exact arranged sequence of numbers. So 1 to 21 because we want to include 20 as well. Okay, then we have printed the print patient. When you do that, you'll just get the entire 1 to 21 with 1 to 20 will get the range of numbers will be printed. So just we want the first A. One is extract first 5 patient IDs. All you have to do is give a colon and 5 that will print the first 5 patients number, and then uh, extract patient ID from 6 to 10. So from the now we are giving the range inside between using columns. Okay, so first the starting number is 5, and then we want to include 6, so 6 and then 10 till 10. Okay, then every second number, what we're doing is we're putting 2 columns, and then uh, you know uh, putting 2 so that every second patient will be printed. So that is it for the fourth question. There are other ways in which you can also do this. You can begin with what like 2, and then uh, we can put colon 2 colon, and then so it's still 21. So 20, so 20 1 if you put, you'll get every other second number as well. You can do it that way as well. I guess this is the shortest way that you can do it. So now is the fifth question. Now this asks us to create a numpy array uh, uh, wherein which they've given us a set of numbers representing systolic blood pressure values. Now we're supposed to print the blood pressure of the fourth patient. We are supposed to extract values for the first 3 patients, extract the last 2 values as well. So we have The fifth question asks us to create a NumPy array wherein which they've given us a list of blood pressures and we have to represent the systolic blood pressure values. So what we have to do is that we have to print the blood pressure of the fourth patient, extract values for the first three patients, and extract the last two values. So what we have done here is we need the blood pressure of the fourth patient. So what we've done here is that the arrays, you know, indexing goes like 0, 1, 2, 3, 4. So which one will be the fourth value? This one. So 0, 1, 2, 3. So this one is the fourth value. So what we'll do, print blood pressure. Blood pressure is the array that we have initialized, and p.array is the function that we have used in order to initialize, and then that will return the 0, 1, 2, 3, like fourth, you know, uh, blood pressure value. Now, this one, what second one we have to extract for the first three. So we have to put colon and put a 3 there so that it will be printing from 110 to 120. Okay, and then for extract the last two values, all you have to do is that before the colon we have to put a -2, which will indicate that we need the last two values. Why we're using NumPy is that it's much more efficient than Python list when it comes to mathematical operations or stuff like this. Much more easier and convenient. Okay, now let's go for the sixth question. Now, in the sixth question, we are creating a one-dimensional NumPy array with 12 random integers between 70 and 200. So it's random. So we are using what? The function random.randint, okay? Representing cholesterol levels or the array in ascending order and print all unique values. So it's very easy. What we have to do is we are initializing. First import NumPy as NPy, and then we are using name cholesterol. I mean, using np.random.random.random as the function, and we are setting the range 70 to 201 because 270 to 200 is the range that they've given. So in order to include 200, we're using 201. Okay, and we are taking 12 random digits. All there is to do is print that, and then that's all. We'll get all the random thing. And so they've also asked us, first we'll get the random array ranges. Second, we'll have to sort it using ascending order. So np.sort. And when you do that, it will be arranged accordingly. Now np.unique will print all the unique values. Everything is unique. So everything will be printed. That's all for the sixth question. Now, for the next question, we have to create a NumPy array representing patient weights. Find the index. We have to find the BMI and indices of the maximum minimum. Okay. So here we are import NumPy as NP weight np.array to create to initialize the given values. Okay, we're using this function, and then we are giving it in. Now what we're going to do is we're supposed to find the BMI. So print np dot where weight is equal to 170. What this does is that it will help us to find the index value. Okay, and np dot these np dot things that we use are the functions in order to do mathematical calculations. Okay, so God. Okay. NP dot argmax, what it will do is find the maximum weight out of everything. It will find the first, it will find the average, then it will find the maximum, and then it will find the minimum. That is what it does here. So index value is 2, and then the maximum weight is 5, and then it's 0. This is how we are finding it. Okay. So let us go for the eighth questions. So generate a NumPy array of 20 random integers between 90 and 200 representing blood glucose levels. Extract all readings above 140 and all readings divisible by 10. So what we are doing is first this as usual glucose initializing np dot random because we're giving a range and we need 20 values between 20, 90 and 200. Okay, and then we are printing the range and then we're printing the values that are less than 140. It's all you have to do is glucose, which is the name of the array that we have given, range of the array, which is less than 140, to print the numbers that are less, and print glucose. Now it will divide the the array by it will give the it will divide it by 10. Okay, and the remainder, if it is equal to 0, it will give those numbers which will give you remainder 0. Okay, that's why using modulus, right? That will help us, you know, get all the readings above 140 and readings divisible by 10. That's all. The ninth question, what we have to do is we have to create two ID, sorry, one dimensional numpy arrays wherein which is given as the height and weight. Now we have to calculate the BMI. Sorry, for the last one I told BMI. I did this already. That's why I told BMI. I'm sorry. This is the question that you're supposed to find the BMI. Okay. So what we're supposed to do is that we are supposed to initialize the array. It's as simple as that. Is see np dot array we've given, wait, np dot array we've given again, BMI just we have to calculate the formula. It's very easy. So weight divided by height divided by 100 into 2. Now this, when you do print BMI, the needed BMI rate will be calculated, answer will be given by the IDA. Okay. Next, what I'm going to be doing is the 10th question. We have to create an array of 30 random integers between 95 and 105 representing daily body temperatures of a patient, and we have to print the total, the highest and lowest values, and the average of the first 10 readings. So again we are doing mathematical operation. Yeah. So np dot random name, so that we can use 30 random numbers between 95 and 105. Okay, 106 is being included, so that we can include 105. Now we're printing temperature. It will print the range. Total, what in order to find the total, np dot sum function is being used. To find the highest, np dot max will be giving returning the maximum temperature. Np dot minimum will be giving us the minimum temperature, and average of the first 5 readings will be given using np dot mean. It will find the mean of the temperatures. Okay, now that is what we have done in the 11th question. Next is the I'm sorry, 10th question, sorry. Next is the 11th question. Again, we have to find, we have to make a one-dimensional array 1 to 12 representing months. And then we have to reshape it into an array with 4 rows and 3 columns for seasonal health checkups and flatten it back to one dimension. So it's months we have arranged it NP 1 to 30. 1 to 13 means 1 to 12. We have 12 months, right? That's why they've included 13, so that it only takes 12, first 12 months. Now, when you print months, you will get 12 months. And then sees if months dot reshape. Now, this function, what it does is that it reshapes. Okay. Okay. Reshape in the sense it will change the order. Okay, 4 comma 4. April season, what it will do is that it will, first it was like this, when it reshapes, it will be like I was saying, what it does is that it arranges the given array into now, say for example, if you are taking the days of a month, it will be arranged in a way so that it will be convenient to see the dates. Like, so that is what we've done here. All right, and then that is what reshape means. This is the number of rows and columns. Okay, now season dot flatten, what it does is that it will take it back to, it will change it how it was, before. Okay, into what it was like before. Now the 12th question, what it says, now 12th question, we have to create two arrays of six random integers between 1 and 10, representing the number of patients admitted in two hospital departments. Perform element-wise addition, subtraction, and multiplication. So here we're supposed to do what? Addition, multiplication, and subtraction. Okay. So first we are doing input numpy as NP. Department 1, we are using random.randit. Now why we're using is to take random numbers like we've said before. Ranges between 1 to 10. 1 to 10 here as well. We are taking 6 each from each department. Now in printing department and 1 and 2, that will give you the array like so. Now addition, what we're doing is department 1 plus department 2, you'll get the added numbers here. Subtraction, we are simply department 1 minus department 2, that is what we're getting, the subtracted values. Multiplication, we're just using the star symbols to multiply everything. I'm sorry, multiply everything. Now that's for the 12th question. Yes. Now for the 13th question, create an array of 15 random integers between 50 and 200, representing patient blood sugar levels. Sort them, extract all levels above 150 and find the unique. So this we've already done, unique values and random again. So NP, import numpy as NP. Then we are using random.randit in order to what? In order to uh, get random 15 integers out of 50. From 50 to 200, we're taking 15 random values. Okay, sugar is the name that we've given to the array, to the randomly organized array. Okay, sorted sugar is the new initialized array, where in which this array is sorted. Okay, and that will be printed. Now sorted array which is less than 150 will be printed next, and unique, np.unique, what it will do is print out the unique values. Okay, which will not, which is only, why you mean my unique value, it won't be repeated again. Okay, np.sum will, what it will do is that it will sum everything up in the sorted, in the name sorted sugar array that we've given. It will sum all the integers within that array. Now this is the 14th question. We are supposed to create a numpy array of 7 floating point numbers representing average body temperatures, and we are supposed to convert its data type to integers and print the data type before and after conversion. So we've taken np.array, we've taken random, no, we've taken 7 floating point numbers. Okay, point numbers we've taken. Temp.dtype will show the data type. Temp is equal to temp.asType int will return the integer values. Okay, now and this will be printed here. That is for the 14th question. Now, the 15th questions asks us to use numpy's arrange and linspace to create arrays. Now, we are creating this using arrange and linspace. Okay. Now, linspace will give will give you space in between. Arrange will arrange everything together accordingly. Okay, yeah. So B, BP with NP dot arrange we've taken 100 to 181 is the range. So 100 to 180 is the range, and 10 numbers we are taking. NP dot line space we have between 120 to 240, and this is the size, and then we have printed it. Okay, now the 16th question is that we are supposed to iterate over this given number of array, and we are supposed to represent the patient's blood pressure readings, and we're supposed to calculate the normal and the high blood pressures. Same NP dot array. Okay, now we are using for loop for this. So for I in BP, okay, I will is the number that we're supposed to take if if it is that is the in, initializing value that we're supposed to use to find out if the BP is high or low. So if I is less than 120, then it is normal. Else, if I is if it's less, then it will print normal. If not, directly it doesn't have to see it is high. Right? It will do that. Now it will go through each and it will print normal. Everything so far is normal. So it is everything. Okay, everything is normal. Out of these arrays, we're checking which is normal and which is not normal. So everything is normal. We are using for loop in order to find this out. Okay. Next is the 17th question. So what we are doing here is we're splitting a one-dimensional NumPy array, and we're representing blood sugar levels into two equal parts, morning and evening. So morning a separate reading, evening separate reading we're taking, and we're going to take that as an array. Morning, evening, we're splitting it as 2. NP dot split sugar is the initialized array into 2. Okay, sugar. Okay, now print morning, which will be the morning, and evening will be evening. So these 3 will be morning and these 3 will be evening. So 18th question, we're supposed to create a pandas data frame from a NumPy array of shape 5. Okay. Thank you. Discuss about the 18th and the 18th question. So this allow this one in this question we are supposed to create a data frame from NumPy array of shape 5 and 3 to represent 5 patients with columns heart rate, blood pressure, cholesterol, and we are supposed to display the data frame. Now why are we using pandas? We're using pandas because we have to create a table. That is why we are using pandas. Now it will create a data frame, in the sense a, a box in which you will have different data. Okay, our data will be arranged accordingly. So so this is the code. Okay, import NP pandas as PD. Given the information, we've given the heart rate and we've given the details. Okay, now what we've done is that we are using, instead of NP, now using PD. So PD dot data frame, and we have given the names and we've specified the row of the column. Okay, here, and then we've given the title like so. All right, and then we have all the things that the names that we've initialized, we have printed it. So when we do that, the column heart rate, patient rate, patient name, these are the things that we've given. Okay, and before that, we've also given the um, names, the heart rates, and the cholesterol of each of the patients. Now, this will arrange all that into one entire box. Uh, yeah, okay. Table. Not box, I'm sorry. Now we're supposed to convert the following into Pandas data frame: a list of patients' names, a tuple of heart rate ratings, and a dictionary with patients' name as keys and cholesterol values. So what we've done is that we have taken pd.read, a CSV file, in which they read all these data, and then df.head will, it is an empty set, sorry, array, and then with dot columns, and df.d types will print everything, every data type as well. Mm, So here we've got all the